Hi, in this section I am explaining a new concept that is called as queue. I think you are aware about queue. What is queue? Queue you can where the peoples are standing from one end and adding from the other end. That means you can see reservations. All those will come. A reservation means the people who are standing for making a reservation for bus, train or flights. You can see. Yeah, that is the same concept here I am going to explain. Here you can see the definition. Queue is a linear data structure in which removal of elements are done in the same order they were inserted. That is, the element will be removed first which is inserted first. Here, a queue has two ends, which are front end and rear end. Insertion take place at rear end and deletion is take place at front end. Queue is also known as first in, first out, that is FIFO data structure. Examples: queues in theater, as now I explained, queues for reservation in a bus stand, etc. That means you assume that this is a line. You can see here A is a person who stands first, and this person only will get out when he get reservation, that is first in, first out. That means a person who stands in a first queue is popped or comes out from the queue. Here you can see in a normal queue also the people will come and join in back side, not in the front side. That back side is called as an rear end. That means here A is there. If B want to join for this line, it should come and join after this full stop, not before A. This concept is called as a queue. Now you can see here, this is DQ and this is NQ. DQ is nothing but it is called as a front end and NQ is called as a rear end. That means the people will come and join at this NQ and the person who is standing in DQ will eliminate first. That means you can see here I have taken 4 examples, that is first value, second value, third value, fourth value. If you want to add a fifth value, you should add after the fourth value, not before the first value. This concept is called as a queue, that is ordinary queue. That means insertion is done at NQ and deletion is done at DQ. Here you can see the operations on queues. There are two fundamental operations performed on queues. First one is insert. We will call that one as NQ. In previous slide have explained the NQ operation is used to insert element at the rear end of the queue and it returns void. Void is nothing but valid output input data. Next you can see here delete, that is DQ. The DQ operation performs the deletion from the front end of the queue and it also returns the element which has been removed from the front end. It returns an integer value. The DQ operation can also be designed to void. Now here there are two concepts. First we should check, that is queue overflow, that is full. When queue is completely full, then it shows the overflow condition. That means when you take an array of 5, if you try to after inserting elements into an array 5, if you try to insert another element after 5, that is sixth element, then it will show that it is a full. After deleting, you try to delete after 0 value, then it show that queue is empty. That means when the queue is empty, that is no elements are in the queue, then it throws the underflow conditions. In overflow, when the queue is completely full, then it shows the overflow condition. Here I am explaining types of queues. There are four types of queues. One is linear queue. In linear queue, an insertion takes place from one end while the deletion occurs from another end. The end at which insertion takes place is known as rear end, and the end which the deletion takes place is known as front end. It is strictly follows FIFO rules, that is first in first out rules. The linear queue can be represented as shown in the below figure. You can see here 10, 20, 30. Now 10 is inserted previously. Now I am inserting 20, that is in rear end after 10. Here you can see. Now if you want to try to insert another element, if the array has space, now I should insert at rear end. That is rear end will move to the next value. Here you can see front, this is rear. As I explained, the above figure shows the elements are inserted from rear end as in previous slide, and if we insert more elements in a queue, then the rear value gets incremented on every insertion. If I try to put another value, what happens? Now it will, rear will get 1 incremented, that is rear equals to rear plus 1. If we want to show the deletion, then it can be represented as this one. See here I have deleted one element. After deleting, what happens? The front also get incremented. In the above figure, we can observe that front pointer points to the next element, and the element which was previously pointed by the front pointer was deleted. The major drawbacks of using linear queue is that insertion is done only from the rear end. If the first 3 elements are deleted from the queue, we cannot insert more elements even the space is available in the linear queue. In this case, the linear queue shows the overflow condition as the rear is pointing to the last elements of the queue. That means here you can see this line I have inserted in a words into in a queue. After deleting, what happens? This line is get empty, and the front will is also pointed here, rear is also pointed here. Now what happens? The space is here empty, but I cannot insert because the F and R is pointing to rear end. This is the drawback of the linear queue. To overcome that one, here we have used circular queue. In circular queue, all the nodes are represented at circular. Here you can see. If it is similar to linear queue, except that last element of queue is connected to the first element. See, here 9 is there. If I make this one 0 to 9, what happened? In circular, I have connected 9 to the 0th element. It is also known as ring buffer, as all the ends are connected to another end. The circular queue can be represented as follows. Here you can see this is front end and this is rear end. The front end is at the position 0. The item inserted at front end 0 is 1. At the rear end 5, I have inserted the element is 11. The drawback that occurs in a linear queue is overcome by using circular queue. I have explained in previous. If the empty space is available in a circular queue, then the new elements can be added in empty space by simply incrementing the value in rear. This I will explain when I am explaining circular queue in detail. Priority queue. What is priority queue? A priority queue is nothing but another special type of a queue that structure which Each element has some priority associated with it. Based on priority of the elements are arranged in priority queue. This is nothing but, as I have said, priority means what? Preference. Here you can see the preference. When the priority value will enter into a queue, what happens? That value is given preference. That means when you can see in the traffic, when the traffic is there, any VIP is come, then it is in traffic they make allocation a space to that VIP to move over, because he is a priority. That means he may be our chief minister or any MLAs or any VIP persons, that means president or any. If the elements occur with the same priority, then they served according to the FIFO principle. That means if both are in same designation, then it will work in the form of FIFO. FIFO is nothing but first in, first out. This concept, I think you are familiar, that when I am explained in round robin algorithms in operating system. Previously we have studied how operating system works. This priority queues also work in same thing. In priority queue, the insertion take place on the arrival, while the deletion occur based on the priority. Now another important concept, that is double-ended queue. What do you mean by double-ended? Double means two, ended means two end. Queue. What is queue? We can insert queue from same end and delete at same end. That means in both end you can insert or delete. The both linear queue and DQ are different as the linear queue follows the FIFO principle, whereas DQ does not follow the FIFO principle. In DQ, the insertion and deletion can occur from both ends. That means if B and R are both ends, this is, here you can see this is DQ and this is NQ. Here insertion can be done and deletion also can be done. In this position also insertion can be done and deletion can be done. The DQ stands for double-ended queue. In the queue, the insertion takes place from one end while the deletion takes place from another end. The end at which insertion occurs is known as rear end, whereas the end at which the deletion occurs is known as front end. Here you can see diagrammatically how I have explained. DQ is a linear data structure because it is line-wise, in which insertion and deletion operations are performed by both ends. That is, here I can insert elements and I can also delete elements. And here you can also see, here also I can insert and I can delete an element. We can say DQ is generalized version of the queue. Thank you.